Hello, Internet. Welcome to yet another programming interview stream by yours truly, Abner Coimbre. If you were here a few minutes before, that never actually happened. So let's just go with that. So I am very, very excited to have the guest that I have here with me today. His name, I hope I'm gonna say it correctly, is Fabian Giesen. He can correct me. He can correct me soon. And I'm not even gonna say anything. I'm just gonna bring him here on the scene, see if you guys can see him. There we go. Why don't you go ahead and unmute yourself? Can you hear me, Fabian?
Yes, I can hear you.
All right.
Hello, Internet.
So thanks for bearing with me. I should have never changed headsets. That was a bad idea.
Mm-hmm.
Like doing that on the last second. But I'm like, oh, it's a new headset. Why not? It's pretty cool. So let's not do that ever again.
Yep.
Yeah. So thanks for being here. Welcome to the Handmade Dev Show.
Thanks for having me.
Yeah, absolutely. Fabian, I'm guessing that a lot of people here already know who you are. Okay.
Maybe
they follow your work closely. I can assure you, including myself. Big fans. But let us pretend, okay, that somehow nobody knows who the hell you are, right? We have no clue, and all we know is that you somehow became this, at least to me, this amazing, successful programmer that we all cower in fear and bow down, right? So, how did that come to happen? So, take me back to Fabian as a kid, right? What kind of interests you had? Paint me a picture of how you came from being Fabian the kid to Fabian the famous demo scener and programming wizard, right? Why don't you give me that whole story? I'm interested.
Okay, so I sort of started programming around the time when I was 6 or 7. I don't remember exactly. And the thing is, so my uncle is actually a programmer. And there were two things he taught me and my twin sister when we were kids. First thing was like when he was in first grade, like he didn't know the alphabet, like in order. Like he knew the letters, but he didn't know the proper order, and he got made fun of it. So he made sure that we knew the alphabet forwards and backwards. Like you practiced that with us just to make sure. And the other thing he tells us is that a byte has 8 bits. True story. Kind of primed from an early stage. And so my dad had this PC in his office, an old 286. There were he used that actually for mostly for his accounts and so on. And at some point he moved offices and went to a new place. And like there were some games on that too that we could only use. Like this was in his office at home, and we could only use that while he wasn't working. We were playing games on there and so on. And then at some point he moved offices, got a new computer, and I got to keep the old one because I was fascinated with that thing. And there was these games on it that I knew and that I was playing. But there was also this mysterious program that my uncle introduced me to called GW Basic, which was just a Microsoft Basic that came with DOS 5.0 or 3.0 actually. That was 3.3 at the time. Later we had DOS 5.0 and QBasic, and that was the thing, and that had all these fancy new features. But I learned programming basic on GW Basic, and it was taught by my uncle. I think he later got me a copy of Turbo Pascal 6 that came had this floppy disk, this 3.5-inch floppy with the actual program on it, and came with a small book. There was an explanation of how to write programs in Pascal. And that's how I started programming, basically.
People are mentioning Gorilla.bas. Do you know about that?
Yes. Gorilla and Nibbles, yes.
Did you ever deal with that?
Programs that ship with QBasic. There are a couple QBasic things. There was also some accounting sort of thing, I think. I don't remember exactly. There were 2 games that shipped with QBasic, and everybody remembers those. And there were some other example programs that nobody cared about.
You mentioned games there a couple of times. Were you an avid gamer?
Sort of. I was a kid, and I just liked playing games.
But were you one of those gamers that would just game for 3 hours a day or 4 hours? Or was it a lot less?
I was playing a lot at the time. It was also so this is, I said, this was when I was 6, 7, and then later. So this was during the time when I was in elementary school.
Oh, okay. Interesting.
I knew how to read a bit before I entered school. Not very well, but I was semi-self-taught on reading. I could sort of read names and so on when I was 5 or so. And by the time I was 6 or 7, I could read what was on the screen and so on. That had the basic stuff, the programming language. By the way, these were also my first English words, print and go to. True story.
Whoa, seriously?
I was German, so that was my first exposure to English was actually basic.
Okay.
Because on German TV, for example, everything is dubbed. It's not like in the Netherlands or various other European countries that don't have this huge market. German speaking is relatively large, so even anything you see on TV, the movies and so on, they're all dubbed. Because it's a large enough market. I think about 100 million speakers or so in Europe. That is just worth overdubbing everything and translating everything. So the movies you see, the video games you see, it's all translated, and you're never exposed to any other language. Whereas if you were, say, grew up in the Netherlands, the movies are usually subtitled. So A, you don't understand anything if you can't read. Somebody has to tell you. And B, you're exposed to other languages fairly early. If you're just consuming any kind of culture. I mean, the stuff talk shows, game shows, news, and so on TV would, of course, be still your language. But anything that's imported media, like Hollywood movies and so on, is just subtitled. So you're exposed to that early. That's not the case in Germany. So English was not this thing I was seeing the first time.
Okay. Wow, it's fascinating how you were involved in all this linguistic environment, right? Not just programming languages, but just other human languages in general.
Well, Europe is kind of more diverse on that axis. Like I said, in Germany, it's not that much. And France is also kind of isolationist, where they very tightly control the language, sort of. And again, they have a relatively large market of speakers, so they do get translated stuff. But in other European countries, it's a lot more fluid. And anyway, so I had this programming thing that was going on when I was still pretty young. And I was playing computer games. Like, I love, for example, all the LucasArts adventure games. Mm-hmm. They were still Lucasfilm games by then. They renamed themselves in the mid-90s or so. So I loved those. They were like, that was the time. So on the 286, you couldn't really play that much. I do remember I did play The Secret of Monkey Island. Didn't have a sound card there. So you had the awesome PC speaker sound and everything. It's all very low tech. And it was like initially a 20 megabyte hard drive. And later that 286 got upgraded to a 40 megabyte hard drive, which is this amazing doubling. But still, like, these games, after you installed them, like, for example, like Indiana Jones and the Fate of Atlantis, or Monkey Island 2, both shipped on 4 floppy disks. And once you installed them, they took 10 megabytes. So that's either half or a quarter of your hard drive gone. So you didn't have that many games installed. Like, you'd install a game, and they could have maybe 2 or 3 of these installed at the same time, and you try to finish them. And especially adventure games, since they had The LucasArts games weren't that bad. Like some of the Sierra Online were way worse, but they had these crazy moon logic puzzles that you basically end up solving by just trying everything with everything. Which is actually, like, if you're a kid who plays with computers a couple hours after coming from school every day, it's a great way to kill time. So you get a lot of mileage out of that game, but it's not exactly a great game design by today's standards. But it was fun. Like, I enjoyed it.
Okay, that's fascinating. And I do have one interesting question for you. Although the chat's saying if you could lower the speakers just a little bit, because apparently they can hear me through your audio end. Yeah.
Yep.
I think that's better. Yeah, because I can't hear myself anymore. I was also listening to myself, so that's a good sign. All right, Fabian. So you're talking about all these games and all these programming languages and things.
Yep.
What I'm interested to know is, let's fast forward on the timeline just a little bit, right?
Yep.
Let's say your early 20s. I'm not sure.
That's actually way too far.
Is that way too far? Okay.
Yeah.
So maybe late teenage years.
So I started doing demo scene stuff, sort of. Like, there was this book about the demo scene, sort of. It's this terrible book. And when I mentioned it, some people who remember it will groan, and that's fine, because I like to make you suffer. There's this book called PC Underground that was just about the demo scene, like how to code various demo effects and that kind of stuff. It was just this, and like the reason people will groan because there was this first chapter that would introduce to like the way sceners talk that was very much like, it's exactly as groan-inducing as like, oh, this is the way the young people talk and so on. And I feel like because the authors who wrote that book were actual demo sceners, it's basically like rereading that chapter afterwards, it felt like they were basically taking the piss. Like somebody asked them to write that chapter and they made it deliberately as groan-inducing as possible. It was really, really bad. But the actual thing in there, so that book had explanations of how to do various effects, some of which were just like, oh, you poke around in these VGA registers. For example, you change the scrolling to do this wobble effect where you change the scrolling per pixel, the pixel scrolling for every scan line. And you could do this sine wavy thing that just made the screen appear to wobble. And you had this thing like, oh, here's how you set up mode X, which is this thing you did on PCs, on VGA cards, to get basically page flipping. So you could double buffer this without, if you had the standard 256 color video mode, you just have 64K in one contiguous range, and there was one copy and that's it. And you would always be updating it while the monitor was displaying the same thing. So if you weren't fast or synchronized, it would just always tear and it looked bad. And Mode X was a way to get page flipping and also get a different aspect ratio, those kinds of things. So that book explained all these basic techniques for just VGA and EGA programming, had a whole register reference in the back for just the VGA card. And also had some fancier effects like, oh, here's how you do a fire effect. Here's how you do like copper bars, which on PC is harder than say on Amiga because like you need to do the synchronization yourself. Here's how do you do like rot zoom. Here's how you do texture mapping. Here's how you do basic 3D stuff, like all that stuff in there. I found that really fascinating, and like I'd seen these kinds of demo things before. So this was the early 90s. There were these shareware CDs that you would get. It had shareware on it, various public domain programs, and they had, of course, also game demos and so on, just basically stuff downloaded from BBSs. I didn't have a modem at the time, not for much longer. In fact, like first time I got on the internet at home was 1998 or so. So this was your connection to the outside world. And you had stuff like the PC Game Programmers Encyclopedia, which was this collection of text files, including one by one Sean Barrett that you might know, explaining texture mapping. There was all these things, and you would just like try to get whatever you could that had any programming information at all, basically. And that book was nice because it came with, was fairly self-contained, had these register documentations, so you could write effects, and it also had a lot of details, like, oh, like here's other stuff you might want to check out, and it kind of expanded you further. So I got into programming these graphic effects, just doing that at home and so on, and basically just noodling around with that. And this was all also in Turbo Pascal, so it was great. It was a great match at the time for my programming skills and everything. You just had these small programs that you wrote. You were poking around in a few registers. and you got instant feedback. And it was exactly like people on C64, where it was relatively low threshold. Like you wrote like maybe 10, 20 lines of code to initialize the video mode, and then you could start poking into memory and you just get graphics appear on the screen, which is just a great way to get started. So I really enjoyed that a lot. So I did that for a while. Then at some point I met another guy. This was from my school, actually. They had this guy who was considering going to this school, and he was basically interviewing with the principal. Mm-hmm. And we knew the principal. Like it was just a personal friend of my parents. And he's like, oh, here's this guy. I'm not sure if he actually wants to go to the school or not, because it was actually a bit far. This was a relatively good school I was at. And so so not sure if he wants to bus over every day, because it would have been like whatever, 40 minutes, one trip every time. So I was like, kind of far away for middle school at the time.
Right.
But like he seems to be interested in the same kinds of things you are. Don't you want to meet? And it turns out we did. And he's also now in Seattle by some crazy coincidence.
Sweet.
Mike Ticka. He's on the Google Deep Dream team, the neural network thing. Like he's one of the guys doing that stuff. So by some crazy coincidence, we ended up in the same place by completely different routes. But at the time, we were both just interested in demos, and we were doing demo coding. And then he at some point had a modem and would actually be able to get demos, and then we'd visit each other all the time and just like exchange effects. And at some point got interested in actually doing demos, but that never really turned into anything, because by the time I was actually competent to do anything, there was not just copying stuff from the book, basically. Like he had sort of lost interest in that and was getting into neural networks, which turned out to be his later career. So, but that really solidified my interest in the demo scene. So then by 98, or 96, we had internet access at school.
Okay.
And there was this thing called the Hornet Archive, this PC demo scene archive where you could download demos. It also had coding articles and everything. So that was a gold mine. Like when I first found that, it was like, holy crap, what is this? Like, where have you been all my life, basically? And so I was like downloading demos like crazy, like every day. And I had to shuttle them over to, home using a 3.5-inch floppy drive. So just carrying a bunch of floppies every day, going to the library, downloading stuff, copying into a floppy, get back home, like check this new stuff out, these zip files that I got from the internet with this mystical knowledge. And so that really got me into actually doing this demo stuff for real. And then by 97 or so, I was sort of starting to outgrow Turbo Pascal. I still love the language, still love it actually, but it was all 16-bit DOS. And by that point, I had this 46 with luxurious 4 megabytes of RAM, and in DOS you could only use 640K easily without a DOS extender. But Turbo Pascal didn't support DOS extenders properly. Like Borland Pascal, which is this other thing, supported 16-bit DOS extenders, but Turbo Pascal, the one I had, didn't. And like the Borland Pascal thing didn't do 32-bit and hadn't really been updated in a while. It's like I didn't know what was going on. It's like, okay, this is kind of weird. And so that's when I got to C, which is Whatcom C to be precise, which was this compiler that games were using at the time that was using like DOS4GW, this DOS extender that everybody was using. That's the one that came with Whatcom C. So it's like, okay, I need to get onto that stuff and do 32-bit stuff, like whatever, like Doomed It, for example. And like at some point it was just everywhere. And it seems like, okay, clearly everybody has decided this is the way to go. I need to get onto that. So I learned C and started doing that up at 98. We actually had internet at home, and this program, there was this program called Cubic Player. There was just a player for mod files, basically. Mod is this Amiga format that just, the hardware supports 4 channels of sample sound, and mod files pretty much directly map to that, where you just have a set of different samples and you can play them at different pitches with certain effects on these channels, and it does the timing. That's the basic idea. These programs were called trackers that did that, and there's several formats like that, and that was basically the way you did digital music in the late 80s and early 90s on home computers. because just sampling the entire thing was just giant. Like I said, you had something like a 40 megabyte hard drive, and there was no MP3 yet. We didn't have the CPUs to decompress that, even if we had MP3 at the time, because that was just way too computationally intensive. So what you did instead was use these trackers, and you have like something like a 200K mod file that has like 5 or 6 minutes of music. So that's how you did music, and you needed these programs to play them back. And Cubic Player was one of these players. That was one of my favorite programs at the time, and then I later discovered that it got open sourced. And I'd gotten to Linux and so on around 96 or so, again, using CDs. Everything was on CDs. You had like these Slackware or Debian, like 5 CD boxes that you would install. So I knew about open source, and I was interested in that kind of stuff. And somebody open sourced the Cubic Player, which was my favorite music player. So it's like, okay, I need to get myself into that action. So on my 14th birthday in 1998.
You're still 14 here. Wow.
Yes.
Wow, you're blowing
That's
my
why
mind.
I said we can't skip my teens.
Okay, go on. This is interesting.
It just stop me if this is getting too long.
No.
But,
Keep it up.
there's a point to this. I'm
Okay.
getting somewhere with this. So 1998, I get this thing on my birthday. It's like, okay, I want to get my code into this somewhere. Like, I didn't know anything about mixing music. I didn't know anything about these tracker formats. These players were already there. Like, I didn't have any sound cards that nobody has. So it's like, damn it. I really want to contribute, but I have nothing to contribute. It's like, what can I do? I looked at this thing like, oh, like there is this docs thing that somebody did in tech, like this like typesetting system.
Right.
And there's fairly complex, like a fairly complete documentation of the whole program. But there was some very, very basic online help for the programs. Like, oh, here's the key combinations, but it wasn't very complete. It's like, okay, like I was looking at this, like, okay, here's one thing I can do. I can do a hypertext help system for this that actually provides proper online help for this program, so that you don't have to look at the printed out manual to learn these keystrokes. It's like, okay, so that's what I did. It's pretty much one of my first pieces of C code ever, and it looks that way. You can still find it on the internet. I won't tell you where.
Okay. Hunting. Chat, go hunt. Go on.
It's a treasure hunt.
Okay.
Good luck. So you had this marked up thing that just compiled all that text into like some binary format that the program would show it. It would use that for online help. And it had the complete text in it that I converted by hand. Like I knew how to parse like a simple file format with some simple markup, but I didn't trust myself at the time to write a parser that would actually parse the actual tech code that generated the manual directly. Mm-hmm. That seemed to vary at the time. So like I need to like figure out a different way to do this, and I just converted it manually. I
see.
That's the kind of thing you do if you're not very sure of your skills and you have plenty of free time.
That's amazing.
So you just spent 2 weeks converting like it wasn't even that much text, but it was in English, which by that time I could read and write reasonably well, but not very fluently. So it was just this grueling work, and it took a long time.
Gotcha.
Anyway, so I had all that crap. And I got my hypertext help system into OpenCV, and that was a contributor. And I got myself into the credits. Yay.
Sweet.
There were 2 other programmers, well, 3. There was Doug, who is the guy who, Doug Jachmann, who was one of the members of the original demo group. He was the one who wrote the manual, and he had contributed a bunch of things, but he wasn't very active at the project at the time. There was Tamil, or Kevy, that was his demo C nickname, Kevy, who had written the player basically written the player for Fast Tracker 2 XM modules. He'd written the player for Impulse Tracker. He'd written a new mixer. So like he was into the guts of this thing, and he had replaced a lot of this stuff and contributed a bunch of new stuff already before it was open sourced. So he's basically the one who made it get open source in the first place. So that was Kevin. There was a 4th person, which was Felix Domke, like, and by the way, not in order of importance. Like by order of importance, probably first Tammo, then Felix, then Dirk, and then me. I was the least important guy on that team because I didn't know what the hell I was doing. But Felix was also a demo scene guy, and he was doing all kinds of low-level stuff. Like he later did some Windows 95 driver you could do that would allow Cubic Player in the DOS box to open like a direct sound device. So if you had some fancy sound card with weird drivers that we didn't support within the DOS box, if you were running Windows 95, you could actually play through direct sound from inside the DOS box, which was this crazy hack. And Felix is also now somewhat famous. Like he has done various things on console, hacking the Xbox 360. Then has given a recent talk at the last Chaos Communication Congress, this hacker congress, about the Volkswagen emissions scandal, where he reverse engineered part of that. So he's been doing this kind of reverse engineering, like really system-y hacking thing for a long time, as long as I've known him. Yeah. But Tammo and Felix were the two guys who really got me into the demo scene, because through them I learned that this demo scene thing was not just something that existed on certain mailboxes and so on that I didn't have access to, but it was actually like there were actual demo parties, and like I knew about demo parties like Assembly in Finland, which is an ongoing thing. It's still ongoing, in fact. Like it has been since the early 90s. Like, well, Helsinki is kind of far away, you know? And then I learned that, oh, there's demo parties here in Germany, like a couple hours drive away. And I learned a couple weeks too late that there was a demo party called Mecca 1998. So it was too late for that. But it was like, okay, next year I need to get into there, which was actually a bit of a problem since I was still like sort of technically too young. Like I was certainly too young to drive, so I needed to find somebody who would drive me there. And this was crazy action where it's like literally like try to find anyone on the internet who would drive me there and who was also going there. And it was this complete coincidence of crazy stuff that I won't get into to even get there in the first place. But there was this, by 1999, they had fused with this other, well, actually, no, it was already 98, doesn't matter. There was this demo party called Mecca and Symposium 1999, which was like the fusion of two original smaller parties. Like, and I was there, like, this was my first demo party, and like, okay, imagine you've been doing this sort of demo coding thing, more like in the abstract, you've done these effects. You know, there's PC demos, and some of them are really awesome, and you know that's a thing. But suddenly, it's not just something you do with a friend or two that you really seem excited about and nobody else really sees the point of. Suddenly in a room with 1,000 people who all think this is awesome. And that you should be doing this, and you have competitions, and it's complete sensory overload because everybody is playing music loudly, and like suddenly you have not 2 people to talk to find this interesting, but 1,000.
I'm sure you felt right at home when you went there.
Absolutely.
Like, yeah. So before you continue with your timeline, one quick question. You told me about your friend who's now working on Google, right?
Mike, yeah.
Yeah. He was interested in the demo scene, and then he sort of parted ways with the whole gaming and graphics things to this other side. What made you want to stay? Like, I've been thinking about you doing the demo scene. I'm like, are you doing it because you enjoy the end result of what the demo scene can produce, right, as a product? Or do you just enjoy the process of creating a demo and you don't really care what you see on the screen that much? It's just the process of development that you enjoy. Right?
Both, actually.
Both.
I mean, it's like these priorities have sort of changed over the years. Like sometimes it's more that, sometimes it's more that, but it really like depends. But in principle, I like both the demos themselves, and I just like the act of creating them, which has this lots of like random like technical programming.
Yeah.
That it was
because of all the constraints too, right? I mean, you were exploiting hardware.
There was this there's a super technical programming that I just really enjoyed at the time. Sort of not as I still do super technical programming, but I'm not as high on it now as I used to be then.
Okay.
It's just, everything has to have every single cycle squeezed out of it and so on. Like the kind of stupid shit you can only believe if you're a teenager, or at least mentally in that state. It's like, no, like you do not need to squeeze every single cycle out of something that only runs once a day or whatever. But like at the time, I was like, no, everything has to be hyper optimized always, and like everybody who's not doing this is a hack, and like don't trust anything that they're saying.
Okay.
I think, that was my mindset at the time. If you're in the demo scene, there was actually sort of a good cultural fit, which I'm not sure it's a good thing, but that's how that was. Gotcha. And that was at Mecca 99. I first got to meet some of these people. Like I first met Felix, I first met Tamil in person, and pretty intense experience. And I didn't get any sleep, almost no sleep, to the point where like, yes, like in retrospect, like this was not a good thing, because turns out like if you're in the sensory overload mode, and as I said, like at the time I was still 14, like took some crazy convincing to get my parents to just sign off, like to just drive off to this weird meeting somewhere in the middle of nowhere in northern Germany with a perfect stranger who was driving me. It was like this crazy thing. But but my parents were cool about it. They let me do it. And it was certainly one of the formative experiences of my life. And I had a great time. And after that, I started really hanging out with these guys more. And fast forwarding a tiny bit, like 1 year later, like I was doing all this kinds of stuff, and like they were doing their own project at the time. And by 2000, we had this demo group, Fabrausch, that they had already founded. Like they were doing a different thing before called Elite Group, which was this parody of elite demo groups of the 90s. Because there were all these people, like mind, again, these are like 14, 15-year-olds who were like, yes, like we're the elite, we're the best programmers in the world. We have figured out how to do backface. Like the subtitle, like these people actually believe this. So like they were super serious, and they got to like, oh, we'll not compete at these demo parties because of the low prize money and that kind of stuff. Oh. So like this super hilarious in retrospect thing. And like by the time like these guys are like, everybody who has been in the demo scene for any time has met some of these guys. They're sort of like that. They were doing this parody demo group called Elite Group that really played this up to 11. It was just like they announced that they would achieve world domination on December 29th, 1999, which they planned to do by releasing a demo, which they did. Called Kasparov. Like they just went all out. It was a great fun thing, but it's like after that, like, okay, like they put out that demo. It was a great demo. It's still one of my favorite demos, actually. Kind of controversial at the time, not least because of the attitude, of course.
Yeah, of course.
Like the final screen is just their logo and like the subtitle, "We are very good." So like that's the whole attitude thing. But yeah, they released that. It was fun, and like, okay, like we did this like for 1 year. It was kind of fun, but it was also a lot of work. And it's like, let's do something that's a bit more chill now. But we still want to work with the same people. So that's how Fabrausch got founded, which is a different demo group that has this completely different thing. Like Fabrausch was really just like, hey, we're a bunch of people who know each other, who just want to do cool stuff and no pressure. Like just do whatever you want. It's basically like this sort of proto-anarchist artist commune, where just whatever goes, as long as you just like, I mean, at some point, like if you're being completely obnoxious, people would want to not talk with you anymore. Right. But there was basically no rules, and you just like everybody just does whatever they feel like, and like, hey, you can sort of form into groups to do these things. Like if you're enamored of some particular idea at one point, you just do that. Nice. So I got into Fabrausch just like, okay, there were a bunch of demos that people were doing. It was like I was hanging around with these guys and basically finagled my way into this. And I had done a bunch of demo-like stuff at the time. There's certain things you always need. Like you're fiddling around with the timing, and you need this to sync up the music, so you need some code to do that. You just need basic, like this was already in the 3D acceleration days. So we need some basic code to set up the D3D stuff, some vertex buffer management, whatever. Basically boilerplate code for that and for timing and for sound. And like I did this demo system thing, which was like the term demo system was already a thing. It's like, oh, you have all this basically backing code that has nothing to do with the actual demo. But basically, it's the infrastructure you need to do that. So like I took the existing code that was there for a demo that was in the works. It was like attempted to be released multiple times, but never finished. It's like, okay, let's put this on some more solid footing, do this thing. And I did the demo system for Fabian, which at the time, I was also in a different demo group with Felix. We were basically using the same demo system. That group was called Witchcraft. We only had 2 demos, one of which was on PC, one of which was on PlayStation 1 at the time. Like that was like his console hacking thing was the PlayStation 1 thing, and my thing was just like, oh, we have this 3D engine that can play lightwave files and so on. It was not a good demo, but was using basically the same code. And it was like, I wanted to do something with Fabian guys, so like, oh, I have this code, let's just do that. And I brought that to Fabian and like did some effects, did some render target management stuff, and suddenly people were actually doing demos with that. And like some of them were actually like they're not stuff I would put on my resume now, but it was fun at the time. They were okay.
Okay.
That was early 2000. And then somebody else, Carlos or Dirk, who was my former boss at another company, was also like hanging around with these guys and did a different thing. I was like, he wanted to do a 64K intro. So that's just a program that's 64 kilobytes in size and displays all these moving graphics, sound, whatever. Because he had this idea like, oh, like everybody was doing 64K intros. So the basic idea is you just write like instead of stating textures and music files, which are large, you just write a program that generates that stuff more or less procedurally. It's not really procedural in the way people mostly use it, since it's not like we're generating a landscape procedurally and it's like a different landscape every time. Yeah. It's more like, oh, we have those basic operations. And rather than having the artist just basically work in Photoshop, they have to work using this restricted set of operations. And we just record what these operations are. So then when somebody runs the program, we can just play that stuff back, get those textures back, and do it that way. And we had that for textures and models, and like Kebby did, because sound was still his thing. Kebby did this real-time sound synthesizer that was actually doing like, this was actually real-time, so just multi-timbral voice synth, multi-voice. Actually pretty cool piece of tech for the time that had all these real-time audio filters and so on, that was playing the music. And then the textures and the geometry was basically calculated at the start. And just fill up a bunch of textures, vertex buffers, and they have some animation splines for the cameras and so on, play all that back. That was the idea for that intro, which was called the product, or FR08, because it was the 8th consecutive numbered Fabian release. Nice. So I had nothing to do with that thing, but I was super fascinated with it. And there was part of this whole thing is you write this whole program, you have this data. And that's still sort of large usually. So what you use is some exe packer. So that's a program that takes the executable code and compresses it. And we're using UPX at the time, the ultimate packer for executables, which is still around, by the way. Cool. Which is one of the ways to do this exe packer. And that's just a small program that just takes the body of your executable, compresses basically all the code and the data that needs to go into it, and inserts a new stub program right at the start of the executable. There's just enough to unpack it, move everything to the right place in memory, and then jump into it. So that's how these programs work. And that's what you use to do a 64K intro. You write a regular program that is sort of too large, and then your exe packer gives you whatever, 2-to-1 compression. So you can have like 130K executable, compress it to 64K, and you're set. The basic framework of UPX was quite good, but I had some ideas just looking at the results of the executable files. I was doing lots of operating system stuff at the time, and I knew how executable loaders worked. So it's like, oh, there's a bunch of there's probably a kilobyte or two I can squeeze out of just rearranging the headers differently. So I did some prototype of that, had a modified version of UPX that did that. And then it was also like, oh, there's this different packer that has this super small depacker. There's a thing called APAC. Has 170 byte depacker in x86 code. So it's tiny and actually compressed better than what was in UPX. So it's like, okay, I'm going to do this fork of UPX, was called FRP, Fabian Packer, that was using APAC and did a slightly different file layout, but not quite the way I wanted because it turned out to be hard to fit into the UPX code base. And that was what the original FR8 was compressed with. And again, I'd written the exe packer, which for 64K is kind of a big deal.
Yes.
Written in the sense that I modified the X, but hey, it was still custom. So I got into the credits. And I'd done some compression stuff before and later started doing more of that and actually doing a full custom packer. It was like, okay, I can't do what I want with an UPX, but I can just do my own thing anyway. And that was a program called Crunchy.
I've heard of that. Cool.
That was just, initially it was using the APAC thing. I was like, okay, let's replace APAC with a better packer. And it's like, oh, like at the time, like, let's do a better compressor, let's do arithmetic coding. And like the version that ended up being used, not just by us, but by a lot of demo scene people, had something like this thing that I'm still quite proud of. The small D packer, something like 300 bytes of x86 code that has like this dictionary compression with an arithmetic coding backend that's all adaptive and so on, using various ideas. It's like, it's not the way I do it now. Like I have some better ideas about that kind of stuff now. Not least because I've been doing it professionally for years now, but it was really damn good at the time. And then Chaos later had an idea, like this was 2000. This Crunchy thing just extends way past that. Like I was maintaining that until 2007, adding new ideas and so on.
Oh, okay.
So this is like once we're in file polish, I can actually start summarizing because we did demos for a while, and then at some point, I was doing a lot of tool stuff and a lot of demo system stuff. And at some point, Chaos was like, oh, we have this idea to make a game using this kind of techtechnology.
Oh, I like where we're going.
Yeah. That was 2000. That was late 2003 where he contacted me like, hey, because at the time, like Chaos did this thing first, then I did my version of the same ideas, like basically wrote a very, very similar tool that did all the stuff that Chaos did. And before he wasn't really interested in me, because like he was like already in his mid 30s at the time, and I was like this still like by FRP days, so like FR8, I was this 16-year-old gawky teenager and still this kind of annoying kid, and he wasn't really interested in working with me at the time. I mean, we knew each other, we respected each other. It's like whatever. By 2003, so now I'm 19, and like I'm a bit easier to deal with, not quite as excitable. He's like, okay, like, hey, do you actually want to work together on this thing? Because like, hey, it's like he did this thing, and he was initially super scared, like, oh my god, like everybody's gonna copy this idea within a couple months. Like a year had passed, and the only one in the world, or in the small world of the demo scene at least, that had copied that thing and basically done something similar that was actually superior in some respects. Like my texture generation was a bit better. We'd done the 64K in 2001 with that. They had really nice textures. It was this invitation to the party 2001. It's called, the intro was FR13. So I'd done that thing like, oh, that actually has better textures than his stuff, and it had some other neat tech things that he didn't have. And he's like, okay, at that point he was actually starting to respect me, because I had done the thing that actually copying this did something better than him, and nobody else had done it in that time frame. So like, okay, this guy's for real, like it's worth talking to. So in 2003, he offered like, hey, why don't we cooperate? Why don't we make this game thing together? And like, that was not just a game, like the idea was also to turn it into a company, which actually happened, but we'll get to that later. So in 2003, it's just like, hey, let's make this game thing. But first, like we have this whole new tool. We had just like rewritten everything. Chaos rewrites everything every time. Like this thing at the time was Werkzeug 3, tool 3. It's like this third from scratch rewrite of his whole tool chain. And I do mean from scratch. Like he would not even keep his type defs. We kept rewriting these things a lot. And like, that's why I'm kind of a bit sour on that, but we'll get to that too.
Okay.
I'm taking way too long on this question, by the way.
No. We're all good. Cool. We're all like, usually this chat is always talking and writing stuff, and we're all just drooling, fascinated by the story. So please, go on.
Okay. So we're doing this thing and doing Vector 3, and it's like, okay, this new thing, but first we need to prove this out a bit and like do some other thing. Like we first like try to get the tech up and did this other 64K intro. And the idea was like, okay, let's get some character animation in there and do stuff with that. That was an intro called Kennytron. So that was proving out some of the character animation ideas, had some very interesting ideas about mesh generation that I wasted months of my life on. Like that's why I know about half edges, and now why I now think they're basically the devil, the way I did them at the time.
Yeah.
It's just this complex data structure that was just terrible. It was terrible to deal with. The code was insane. Like the invariants don't fit in your head. You can't even draw the thing on paper.
Wait, I got lost. Was this data structure something you designed?
The half edges are standard data structure in computational geometry.
Okay. Gotcha.
It's just this thing. Like you have this thing that's supposed to represent a mesh. And I was initially faced with the problem like, okay, I have these problems that I don't understand. It's like, what is the simplest thing I can draw? It's like, I'm trying to unwrap this cube and show up all the stuff, like all the half edges, all the elements in the data structure. It's like, initial attempt to sketch is like, this doesn't work. I need a bigger piece of paper. Got this giant sheet of paper, so I had enough space to do the annotations. Like, still, like, this cube is too complicated. I can't wrap my head around it. If a non-tessellated cube is too complicated a thing in a mesh data structure to draw, and like actually be able to wrap your head around it, that's like, okay, that's the first sign you're in trouble. So after that, I was like, okay, let's do a tetrahedron, which is literally the simplest closed solid you can do. Like there's no way to get any simpler than that. And the tetrahedron I was actually able to draw successfully and how it all linked up. So like that whole data structure, that was just like, there's just 4 pointers and everything, and it goes back and forth. It's just like killing me. It was really, really bad. And because we had all these extra problems that nobody in the literature talks about. So you have these things, mesh data structures, like the way everybody presents it in geometry is like, oh, they're assuming you have like this mesh, and it's just this closed thing, right? You just have points, faces, and vertices. It's like, if you're doing actual 3D graphics, meshes don't work like that. You have on the vertices also things like texture coordinates and normals and colors or whatever light map things. Like there's these multiple attributes, and some of these are discontinuous. And there's stuff they're telling you is like, oh, like, yeah, hard edges are hard or whatever. Discontinuities in the attributes are not something we think about because there's just one vertex and you're just like, what the fuck are you talking about?
Right.
That's the thing I need the data structure for. Like if I'm trying to represent a mesh that I'm trying to work on, I need to deal with this. So you have all these extra difficulties. Like this data structure is complicated enough to begin with, but the thing you actually want to use it for is way more complicated than that. It was crazy.
Jesus Christ.
So that was my first exposure, like real deep to like how bad some of these papers are. And I now know what papers I should have read at the time.
So you think they're
actually
good
get a
papers?
decent exposition of the data structure that talks about these things.
Yeah.
And by the way, there too. Like this is a 40-year-old or something data structure, and there's like 2 or 3 expositions of that actually deal with this. And I say 2 or 3 because 3 is my exposition of this that I've now found. Like I've written this stuff up so nobody else has to go through it again, and it's on my blog, but it's really, really, really bad. So that was my first exposure to that kind of thing. We also had this mesh compression thing that we needed, where we had this whole mesh of this animated chick that we did that had like bones in it and so on. Like the mesh was something we're storing. And like, oh, we also do mesh compression. I was reading mesh compression papers. And there were lots of algorithms that were just way too complicated. And then some that actually seemed feasible and that we ended up doing. And I learned a lot from that. And there was one algorithm that seemed sort of near in theory, but I didn't understand all the pieces of it because it was using mesh duality, which I wasn't really sure about at the time. There was a different algorithm that was basically the same idea. The papers actually came out like 3 weeks from each other and referenced each other because the authors had submitted it to the same things and met that way. So they knew this was coming out. They had different perspectives on basically the same idea. And these 2 papers came out. And the other paper was more explicit in terms of faces and vertices. And it's like, oh, I understand this. So let's implement this. Which, again, in retrospect, turns out to have been the wrong choice. The other algorithm would actually have been way simpler to do than what I ended up doing for the one I picked. But whatever. So I had this thing where it's like just trying to implement an algorithm for a paper, which is just doing that is just daunting. Because it turns out that researchers are sort of in love with their ideas and really want you to use them.
Yes.
And they'll describe the high-level idea, and they'll cover some of the details that they remember to mention. And if there's some parts that the algorithm doesn't really do very well, even if they know about them, they try to either play it down or not mention it at all. So papers are sort of deceptive in that way.
Okay. So this is
Where,
a trend.
like you read this and it looks so simple, and then you try to implement this and it's like, oh my God, how is this ever going to work?
Wow.
So had a lot of fun with that. And the interesting thing is, the reason why I'm going to this whole 64K thing and the demo scene to begin with is that it really profoundly shaped my thinking. That I had done 64K intros, I'd done some 4K intros, like actually one, and I contributed to some more. So like these really tiny programs. I've done some crazy size optimization things with like whatever 64-byte intros. I've done a few of those. So what that does, if you think a lot about these kinds of things, turns out you write 64K intros not in assembly or anything. Like you have some assembly in it for sure, like if you have tight inner loops or whatever. But mostly we wrote them in C++. Same thing about everything else. And mostly it's just about making sure you're not depending on the standard library. You can't use any other libraries that don't come with the system. Like you have to use OpenGL or D3D to use 3D acceleration, and that's stuff that's actually pre-installed on your computer. But you can't have any other random code that is not on every Windows machine and depend on that. So what that means is that basically anything you need that is not super generic and that every app needs to solve, you just need to do yourself. And you only have like a couple of kilobytes of code to do it. It's actually surprising how much code you can fit into a 64K intro. Like you can have over 100K of uncompressed code and like still fit it successfully into a 64K once the compression is done. But basically, there's still this problem, like every byte of code that actually ends up in the executable has to count. Like there's no slop there. If you have a normal program that you write, there's this surface area kind of thing. It's like, oh, like there's this small part, the user interface of the program, that the user actually sees. And how complex or simple that is profoundly affects the user experience, but it's really all it does. And like the other stuff, like what actually goes on inside the program, if a user notices it at all, it's usually through something like error messages. And then you get some incomprehensible error code that tells you like 3 layers down from what you actually wanted to do, something went terribly wrong. You have no idea what went wrong or what to do about it, and the program really doesn't either, which is why it's showing you the error message that's just completely uninformative. In a 64K intro, you don't care about the surface area because you ship the entire thing. So the volume matters because the volume is the size of the thing you actually ship.
Yeah,
so
true.
You can totally have abstractions, but only if they actually pay off. You can't just go like, oh, like I'm going to build this giant pie in the sky framework and write like 100 different classes that are talking about nebulous things. Like you can totally have abstractions, but only if they provide actual value. So we have this dynamic array thing in 64K intros. We had this array template that was even type safe. Because turns out if you write that very, very carefully, basically it turns into no code, no executable code anyway.
Yes.
And it's super nice to have. But what you don't have is these giant frameworks of wrappers upon wrappers upon wrappers, where none of them actually do anything because you can't afford that stuff.
Right.
That eats up code size, which you don't have. And so that part has profoundly shaped the way I think about code, to the point where like I actually think about code size explicitly or implicitly in everything I write. It's not something I can really turn off at this point. Like even last year I was playing a lot of this game TAS 100, which is this programming simulation game, basically, where you write assembly code for a fictional parallel machine, which is this fun thing to do if you're into that kind of programming. But I wrote these kinds of things, like other people like I knew were like, oh, we're optimizing this for cycle counts because that's one of the things it tracks. And like optimizing this for cycle counts is this really interesting parallel problem. And I would also always do like ones that were optimized for the number of nodes and instruction counts. Like some people would ask me like, why are you doing that? Like this machine in that fiction anyway has 2 million nodes. Why are you trying to minimize the number of nodes or instructions? There's plenty of space. It's like, I can't turn that off. And it's just fundamentally tied to my understanding of complexity. Like the code size, like how much code you throw at a problem. Is really fundamentally a notion of how complex that solution actually is, objectively. I mean, a lot of programs have these 30 megabytes of DLLs to do something, mostly to do things that they're not even using. They just ship with it because they just throw it out there.
That's 100% of all DLLs right now.
Yeah. And like these programs that just basically are a message box but ship with all of Qt.
Yes,
that kind of thing.
exactly.
You just have a lot of that.
But do you consider...
And I'm not slamming that. I'm just saying, like, that's a lot of complexity. You're throwing at a very, very simple problem. And if you're doing a 64K or 4K intro, that is the one thing you cannot do. You can use higher level languages. You can use C++. You can even use templates. Probably not exceptions because they require a lot of infrastructure and like other data structures about your program that actually bloat it up. But you can use a lot of fairly advanced techniques. But what you positively cannot do is throw in lots of code that don't solve an actual problem. Because every single line of code that actually ends up in that executable needs to be solving an actual problem. And I think that's an actually very, very useful perspective to have. It's not something you would necessarily apply to a commercial software project, not least because that kind of knowledge of what is actually solving a problem that you really have and what isn't, that's not knowledge you easily have in a complex software project. Because you have different people working on a large program usually, and they understand their fiefdom, but a lot of people don't have the whole big picture, and they can't be obsessively pruning like their part of the solution to solve exactly what is required, because the next day somebody else might check in something that depends on behavior that you just threw away. You just can't be doing that. Right. So 64K and 4K intros have this interesting property where you have like a top level decomposition of the program in terms of like division of responsibilities. But the overall complexity and the overall code size is this problem that fundamentally doesn't decompose. You need to be keenly aware of absolutely everything that is in that program and whether it's worth keeping around or not. So it's this interesting thing where you write this small program that is objectively tiny. It is really tiny, but you need to keep literally all of it in your head at all times. And we had this thing initially, like the initial stuff we did, both FR8 and my FR13 thing, had this thing where the editor and the actual demo were these completely separate programs, and you just end up duplicating a lot of code and merging back and forth, and it's really bad. You don't want to do that. So at some point we were like, okay, we want to share at least the code that's actually common, like generating the meshes and so on between these two things. And they depend on some sort of common infrastructure, so that infrastructure actually needs to be common between the editor and the runtime, which it didn't used to be before. They were just completely separate. So now we're trying to actually share that code between the editor and the demo. And then we have the demo runtime, which just has the shared bits and basically some very simple stuff just to actually play back the thing. Whereas the editor has a full editor and has more environment. It isn't trying to be tiny, whatever. So it can be much larger. So we did that, and that was a big success. But it also means that suddenly everything that's in your editor, because it's sort of entwined with the things that everything in the part that actually needs to go into the intro. Like it needs to be manipulated. If it goes into parts that go into the intro, it needs to be using data structures that they can understand, because that's all they have. So suddenly there's two copies of everything. There's the basic version that has just the essentials that need to go into the intro and that actually need to be stored. And there's some annotations for the editor, like whatever, what things are named. Like you could name things and have shortcuts and various things. That's very important from a UI point of view. But like the names are all stripped out by the time we generate the actual intro. So that kind of thing is now separated. And the interesting consequence of this is you do all this thing, and now you have the small, tiny intro kind of player that really has this constraint that you have to keep it all in your head at once. There's some tooling you can do, like we have these tools that show you the code size for various functions and so on, and can track that even through the compression. But fundamentally, you have to know what everything is in the program, what it's for. Like you look at a map file and you have to be able to point at every single function and answer the question, why is that here, and have an answer for that, or you won't be successful at this. But you also have this way larger editor, which was at the time already, like by the time of Candytron, the 2003 intro, like we had hundreds of thousands of lines of code for the whole editor environment, whatever thing, and just various surrounding tools. There was a lot of code in there. And that's tied up with this part you need to keep all in your head. And then artists request a feature because like, hey, this is really awkward. We'd love it if you'd be able to just do this thing. And it just completely doesn't mesh with the way the problem is represented in the code. Just like, it's this thing that really doesn't fit. And suddenly, like you have this mental model that's just like, it's just exploding in your head. It's like, oh my God. And you have this almost nervous breakdown. It's like, yeah, like literally this changes everything in a way like, I have to rewrite half this code. This is terrible. Because again, this complexity, like normally in software development, you do everything you can about modularity and so on to try and contain this kind of complexity. And the 64K thing makes you work in a way where you really can't, because that complexity like is part of what you ship. So you have to be thinking about it at some point. And you just drove both Chaos and me to this point where like, no, like stop. You just have to stop asking for feature requests at this point. We had these meetings where we would just rent this vacation home in Denmark for 2 weeks just to work on demos. And like the artists would have like, oh, like would be doing stuff and like would be running into crashes and would have feature requests. And at some point on one meeting was like, both Chaos and me were just super annoyed with people, like super short, and they were getting frustrated. It's like Chaos was like, no, seriously, you just have to stop asking for features for at least 1 day or two, because like both Fabian's and my heads are literally exploding right now. It's just completely crazy. Like we're just staggering. We couldn't deal with it because everything was important, and he couldn't keep it all in our heads at once. So this is a crazy thing that we're doing, even though it was this 64K thing. This was actually happening while we're doing the game after that. This is 96K game, which is even more complicated since now you not only have the procedural generation parts and the editor parts, there also needs to be a game there somewhere and have a physics subsystem, and you need annotations for the collision, and it all needs to be small. And oh my God, it was crazy. So that was basically our Waterloo right there. It's just like, just noticed both of us at the same time at this point, like, no, we've not just found where our complexity ceiling is, we've actually exceeded it by a substantial amount, and now we need to deal with it, like basically pick up the pieces. And that's a super valuable experience to have as a programmer.
So
I consider myself blessed to have that. Like this was in 2004, so this was when I was 20. It is a super valuable experience to have at that point in your programming career, because that is the space. Like suddenly, like, okay, you know how to write programs, and you're sort of getting confident and cocky, and you start to gravitate towards over-designing everything. Like, I have the solution, right? I know how to design complex things, and you go way overboard on complexity because you feel like you can just do it. And exactly at that stage of my growth as a programmer, I had this experience where I have this program that does all these clever things, and it's just completely growing over my head. It's just like I realized this really, really deep realization, like I'm in way over my head. That is an experience you absolutely need to have as a programmer. That is actually important. And like nobody can have that experience for you. But if you never have that experience, what you'll end up doing is write the software that basically, like, you may be within your fiefdom, be able to manage all that complexity. but other people who need to deal with one piece that you wrote and something that somebody else wrote, right?
Yeah.
They need to keep both of these systems in their heads at the same time, and it just doesn't fit. Wow. And now they're in the spot of trouble. And they're like, oh my God. And they're ranting about your code. It's It's like, and you're like, why? This is all fine. It's like, no. Once you have to fit like 3 or 4 of these things in your head at the same time, it is absolutely not fine. It is terrible. And
but
that experience is one that you need to have.
Yes.
Having that experience with your own code, mind, so there's nobody else to point fingers at. Like if you have this framework that goes over your head,
sure.
which is easy because they're huge.
Yes.
Like it's easy to point fingers. It's like, yes, whatever. Qt code totally screwed me there. And like, they're probably morons. And if they hadn't designed this that way, like this would all be fine. The problem is like these frameworks need to be a million things to a million different people, right? Because like people try all things to do with Qt. And like that is their strength and weakness at the same time, because they're forced into that complexity. Like that is what people want from them. That's what people expect from these frameworks. Being able to just heap up a bunch of code at a level where it's just like, okay, this is actually reasonably well structured, high-level C++ code, but it has all the conceptual complexity and thinking about it as some monstrous million-line assembly language program, because that's what you're thinking about all the time. Yes. Having that experience and realizing like, no, I've really dug myself into a hole here, and I need to figure out a way to make this work. That's really, really useful. Yeah, well, it's an experience you have to have yourself.
Now, okay, there's so much to unravel here, right? It has been an hour, so I'm going to go into break mode soon. But there is one question, and that is, you know, and I always hate that I ask these speculative questions, but I have to. Just imagine that you were born in 2015, for example, or not even that. Let's say you were born in 2001, right? And you're now in the space where you want to be a programmer, but you already have all these, I'm going to say, bad libraries or huge, overly complex libraries, and colleges trying to make you leverage these tools without, quote unquote, the famous thing, don't reinvent the wheel, right? Do you think that you would be the same programmer that you are now if you were brought up on that environment? Because it seems the demo scene was the one thing that really clicked in your head. That's like, oh, you know, code size and being able to understand the size of your assembly instructions and the complexity that you go as it grows. That came out of the demo scene, I think. But I'm not sure if you were able to have that experience if you were born a few years ago, for example. What do you think?
I wouldn't necessarily agree with that. So,
really? Okay.
The reason I came into the demo scene was more like I thought in a certain way to begin with.
Yeah.
Because like the way you gravitate towards this really technical coding is you see this piece of machinery and you want to take it apart and understand how it works, right? But there's a fundamental mindset that a lot of engineers have. And that's how a lot of people get into engineering in the first place. You see this thing, like that's another thing to bring up my uncle again, because he also had that mindset. Like he had this thing as a kid where people would give him these mechanical toys. And he's like, I don't want to play with these. I want to take them apart and see how they work. And then these people get really mad at him because like, we gave you this thing yesterday and it's already broken. What the fuck are you doing? And so he'd just start asking, like, if somebody was giving him something, like, am I allowed to break this? And if the answer was no, he didn't want it. So that's been kind of my mindset the same way. Like, am I allowed to break this?
Oh, I see.
And the nice thing with a computer is it's very hard to actually break these things.
Yes.
And, like, there's few things you can do with a computer that will break in worse ways than just having to reinstall your operating system. I mean, that's a drag, but it's not like that thing is irrecoverably screwed now. It's like there's always like a way to do that. I mean, that's the greatest thing probably about computers is that you can do that.
Yeah, that's true.
Like there's few things that you can do with a computer that, like, if it's your own mind, like if this affects other people, that's a different thing.
Yeah. And
I'm feeling very ambivalent about hacking into other machines. If you end up screwing up other people's data, that's not okay.
Yeah.
But as long as it's your own machine that you own as your data on it, just do whatever what you want. That's the great thing about computers, is that you can do that. And that at any piece, like especially for PCs, there's actually now with the internet, there's docs on everything. Like some random pieces of hardware, there may not be docs for, but even for those, usually by this point, you can see at least the Linux device driver. So if you truly want to understand how something works, there are absolutely the resources out there to do that now. And even more so than there was when I grew up. It's like I had to deal with there was no internet.
Yeah, that's true.
There's not just look up the part number for this thing, or I want to do sound, how do I do that? You needed to find the right book to buy, and they'd be out of date, and you'd just not be able to find any of that stuff. These days, if it's a piece of hardware that's in an actual machine, there's a good chance there's actual docs for that. It might not be very complete, but the docs I had in the 90s weren't very complete either.
Okay.
And there's drivers that actually implement this stuff and work. So if you want to truly understand how these things work, there's absolutely a lot more discoverability about that stuff now, I feel, even than they used to be. You're also a lot of layers higher now than you were on, say, a DOS PC, where you could just start poking hardware registers directly. So in that sense, it's harder, in that you start out somewhat more separated from that underlying truth, quote unquote, of what the machine actually is like. But there's no question that if you want to truly understand how these machines work, they've gotten a lot more complicated. These machines will not fit in your head anymore. Like a modern GPU, I feel confident in saying nobody actually understands. There's people who understand the high-level picture of a modern GPU and can't tell you anything precisely about the details. And for every single small submodule, at every hardware company, there's the guy who has that thing in his head and understands precisely how that thing works, but isn't exactly sure about what the other pieces in the GPU do.
Yeah.
But that whole integrated knowledge of that whole piece of hardware is in somebody's head doesn't exist anymore.
Okay.
The same way that in a large software product, you don't really have that kind of knowledge.
So not even the hardware engineers understand it. So you can sort of see the CPU as this emergent system that you just have to poke around with. Wow.
Yeah.
Okay.
And that's also that's a real thing. If you look at forums like Beyond 3D, and the performance in that thing is bad because the memory bandwidth is bad, and blah 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 blah. I assure you, that kind of stuff sometimes happens, but more usually, there's no answer to why is this chip slow. There's not a single component you can point at this thing, this one wire. There needs to be two of those. That's not how that works. These chips run multiple workloads, and the bottlenecks move around all the time, and people spend years. If you look at the current console cycle, I know people who just basically, whose job is to diagnose performance problems. That's a full-time job, and they literally spend years paging in the relevant details of all the hardware building blocks to be able to answer what is the performance problem in these common scenarios that they usually encounter. And sometimes they see something they've never seen before, and then they need to look at the spec, and then the spec doesn't contain that, and then they need to do a phone call to the architects, and everybody is confused. And then it turns out some circuit designer did something differently than what it was supposed to be because it was a timing problem. It's these kinds of things happen all the time. So anybody who tells you I understand how this thing works completely, and this is the problem, they're just full of crap.
Bullshit.
Yeah, that's not how that works.
All right, so before we go on break, I want to ask you one last thing. How did you make it to the current company that you're in? Because since you went on this interesting conversation about demo scene, but we still don't know where you are today, right? So take us there.
Okay, so 2004 we did this Kriga thing, and we were starting a company at the same time.
Yeah.
The reason for that is actually kind of silly. The idea was we're doing this FPS shooter thing, which legally is a bit tricky situation to be in Germany. Because games shooting people are kind of a legal risk and something of liability. Turns out we were way too worried about that. We were so we wanted to have a limited liability company. So we founded one that was the owner of that property. In case anything goes wrong and somebody sues us over something, It's just like, okay, like we can bound our losses. And since we were all like, oh, we have real lives, like me, I was just a student, CS student at the time. It's like, I don't want to be like in debt for some legal shit over some 696K thing I did. That'd be stupid. So like we were all like, okay, let's not do that and just make it a limited liability company, which is what we did. We did that in 2004 and then did some contract work, including several things that just ended up being very, very bad ideas. just grueling projects that went on and on and on. And just like, so remember, like I was a CS student at the time. Chaos was actually like, he had his own company at the time. So he had his own game company and he was the technical director there and lead programmer for the technical parts. It's like he had a full-time job and did something like 3 or 4 hours of programming for demo scene stuff every day on top of his full-time job. And then we also, like, we're still doing the demo scene stuff. And then we also had the product thing where we had some contracts that now we needed to fulfill. And that was just too much. It was just too much for all of us. It's like, that was just really, really bad. Because trying to do that while simultaneously also having the demo scene hobby and doing a full-time job is just too much. So Chaos and me both hit burnout in 2007 on this thing that was kind of this side project, which is just kind of a crazy situation to be in. And that was pretty bad. And that's something that I sort of still haven't recovered from, actually. Like before that time, like programming was actually something I really looked forward to and enjoyed. And that's just gone now. Like programming is something I do that I happen to be really, really good at.
Oh my God.
And like sometimes I have these moments where I really enjoy them. And other times it's just like, more of this crap, right?
Oh my God.
And a lot of that is just dealing with the shittiness that is modern platforms. But like it doesn't help to have been in that mindset to begin with, where you had this super grueling, non-rewarding thing that never went anywhere, just to fulfill contracts with companies that you didn't care about these contracts much to begin with. They're just shitty projects that you thought were a good idea at the time. And then you're stuck with them for the next 1.5 years, you know? It's just bad. So that was 2007, 2008 or so. At that time, that was around the time I actually finished a university and got my degree.
Okay. What major?
Computer science.
Which major?
Sorry. Computer science major and with math minor.
Cool.
So university didn't feature much. It was like in this explanation because it really wasn't a very formative experience for me. It was something I felt like I should get a degree. So like I have a formal certification that I'm actually good at this, basically.
Yeah.
Like the whole thing that I did with getting the CS degree was basically like, okay, like I know the CS parts are gonna be fine. Like I didn't sweat that one bit. It's like, let's use this time. Like I wanted to get a bit more into math because that's also always something that's been close to my heart. I basically used that time to just get my degree, but also use the time to just learn the stuff about math and go to a lot of these lectures, all these subjects that fascinate me, and do a lot of that. So that was basically my degree. The computer science parts of it were like, oh, okay, whatever. Like it was actually useful in a lot of things. So like I got a lot more theoretical grounding on some of these things than I would have otherwise. So it's been actually valuable from that angle. Not so much in terms of like this taught me to be a better programmer, but this gave me a better understanding of what's been there before. Like because you learn, like if you actually listen at these courses, you learn a lot about computer architecture. You learn a lot about history of algorithms, like what people have made kind of interesting discoveries.
Yeah.
And you get a lot of leads to follow up on if you care, if you want to actually understand this field as a whole. So on that front, it was definitely valuable. But other than that, like it was just never a thing where I felt like I was in danger of not getting my degree. It was just this thing like I should have this. It would be professionally useful to have this, and basically maximize the time of interesting exposure to other things I can get while doing that.
Fair enough.
So 2007, I was starting to finish my degree. 2008 was when I actually got my degree and I had to do my thesis and so on. And after that, I went to this game company, Chaos's game company, in fact, called 49 Games, where we did relatively uninteresting, quote unquote, sports games. Just like this thing, we're like, yes, every year we make 2 of these, in fact, one winter sports, one summer sports, whatever. It was just this thing that the company had kind of walked into, if you want to say so. Like, it was just, they were doing, initially they did this racing game, and then they got a contract with a German TV station. And it was like, okay, we need to do anything to basically keep this company afloat. And they did the ski jumping game and sort of became winter sports specialists during this whole thing. It was never something that everybody was really, really super happy with. It was just something they ended up doing. And they kept delivering and they kept selling well. So it just kept going on. The publisher always wanted them to do more of that. So they ended up doing these sports games. And I was there for 1.5 years. And then got an offer from a certain guy called Jeff Roberts, who was asking me, like, hey, I'd met, well, quote unquote met. I knew about Casey from way before. He had this forum, the Molly Rocket forums, about programming and so on. That he was, just like this community, and I had found Casey's stuff. Somebody linked me to it. I don't remember where. I'd found it sometimes during university. Like some link on him doing quaternion interpolation, these long rambling mails of Casey explaining quaternions. It's like, oh, this guy looks interesting. Like, just pay attention to what he does. And at some point, he opened these forums, and I was hanging around there. And Casey was on there, and Sean was on there, and Jeff was on there. And so at some point, it was like, okay, Jeff just sent me a mail. Like, hey, we're doing this thing called Larrabee, which was already sort of disclosed at the time, for Intel. And like, we need more people here to do what we're doing. And your salary would be like 5x what I was making at the time. And like, are you interested? I was like, hell yeah.
Oh, fuck yeah.
That's how I basically ended up at Rad. Like, Casey had actually sent me an email early in 2007, already asking if I wanted to work at Rad. But that was before I even had any job. Like, at that time, I was still living at my parents'. It was like, okay, like, let's take it slow. Maybe not do the whole culture shock thing of just moving out of my apartment, just having my first own apartment, my first job, all at the same time, with also moving to the US and to somewhere where I don't know a single person. So it's like, that'd be a bit much. Let me give you some time, like, get back to me later, basically. So in early 2009, literally 1st of January, I remember that, I got that mail from Jeff. Is that I'd been at a party before for New Year's Eve, and I'd gotten flu somewhere there. So I was feeling sort of sick and in a haze, and I was reading that mail. It's like, what the hell's going on, man? But yeah, I got basically an offer I couldn't refuse and didn't want to.
Yeah.
Next week, after I felt better, I talked to my bosses, like, hey, I got this really great offer. And they were just like, man, look at that. Like, just do it, man. Just do it. This sounds way better fit for you than the stuff we have for you to do here. So that, yeah, you should totally do that. So I did, and that's how I ended up at Rad.
And you're still there, right?
And I'm still there. Sorry, that was early 2010, not early 2009, but yeah.
Okay.
And I'm still at Rad.
Nice. Can we ask how old you are? People are saying different ages.
Sorry?
Can I ask how old you are?
I'm now 31.
You're not 31. Oh, you're
I'm
now
31.
Oh, okay. I got it. Cool. All right. Wow. This is all truly fascinating, and I'm eager to ask you more questions about, since you brought up Rad Tools now and Casey and all these things. You know, this is the Handmade Dev Show, and we were inspired by Handmade Hero. And there are some interesting perspectives that I really enjoyed that you've voiced in Twitter and things like that. And I want to get into that after this break. So if you don't mind taking a 3 to 5 minute break so I can use the bathroom, refill my drinks, right?
Sure, fine.
Have people, okay, chat, go ahead, use the bathroom if you need to, do whatever you need to do, and we'll be back in 3 to 5 minutes to keep talking to the coding wizard, Fabian. How do you pronounce your last name, by the way? How do you pronounce your last name? I'm sorry.
You pronounced it correctly.
Yes.
Fabian Giesen.
All right, cool.
It's the German pronunciation, but he did a good job.
All right,
way better
good.
than most people do.
I was so worried. All right, all right, guys. Why don't you go ahead and mute yourself, and I will call you out again. So,
Okay.
All right, chat. See you guys soon.
Back in 5 minutes.
Yeah. Hello, Internet. Welcome to the second part of the Handmade Dev Show. This is a show where we try to get interesting guests, and they're usually, or 100% of the time, they're successful programmers or aspiring programmers that um, want to share or would like to share their perspectives and thoughts on programming. And we've been talking to the amazing and the one and only Fabian Giesen. Um, he works at RAD Game Tools Company, and he's been a demo scener, and I call him a coding wizard just because of the things he's done with compression and with the graphics pipeline and so many other things, right? You guys can see his website soon enough. If you're tuning in right now, then you missed the first part of the stream, which was amazing. He was talking about his life, the way he grew up, learning about languages, both human languages and computer languages, how he became a programmer, how he got into the demo scene, how that helped him become a better programmer. And in the second part, I'm going to be asking him a few questions, and then after that, you don't get to listen to me anymore. All right? I'm sorry. We're going to listen to you guys. So make sure you have your questions for Fabian ready. Type them in, put them on your clipboard. And then once it's time for the Q&A, I will do my best to answer as much of them as I can. But for now, let's go back with Fabian and let me see if he can actually hear me or not. Fabian?
Yeah, I can hear you just fine.
All right, awesome. So it was awesome. You ended, talking about the company that you're working for, RAD Game Tools Company.
Yep.
And, Casey Muratori was part of that before he left to work full-time on Molly Rocket. Am I right?
Yep, that's correct.
All right. And he recently, a little over a year ago, he started this series called Handmade Hero.
Yep.
And I will encourage the moderators to post the link to Handmade Hero and check it out if you're a new person here. But handmadehero.org, handmadedev.org, which is what you can see right there below my Twitch window, is the thing that was inspired from Handmade Hero. And it's this community where we really appreciate programming things from scratch. And by what we mean from scratch is, we're not leveraging a lot of libraries that have been created for us, and we're trying to solve these problems ourselves, even if we are, quote unquote, reinventing the wheel. And, I've been a big supporter of it to the point where I, started Handmade Dev and have amazing developers working on it like Kelimian and Chrono Dragon and the community at large. They're working on this website where we have a hub of people trying to make projects like Handmade Hero, where they are doing things, again, from scratch, quote unquote, and just trying to solve problems even if you are looking at it from a different angle, or if you're not reusing libraries because we think they're bad currently. That's what we're trying to do. And Fabian has given some interesting thoughts on that has really perplexed me in a way that I want to know more, because I like understanding perspectives like the ones that you have. And, what do you think, if you're okay with answering, what do you think of Handmade Hero? What do you think of Handmade Dev? And are we approaching things in the right way as a way to have young programmers learn how to do these things at a low level? Or do you think that the end result of our project will give a positive impact on the software development community at all? Like, what are your thoughts on the whole thing? Like, just a high-level explanation of what you think of all this.
Okay.
Whether it's positive or negative, I don't care.
And that I think I know what precise statement you're referring to, and I think you got it the wrong way.
Probably, but I'd love to know, though. I'd love to know.
Yeah. So, in general, I am absolutely cool with people writing stuff from scratch to understand things. Like, that is pretty much the way you have to do it if you want to actually get the way it works, at least in programming. There's this quote attributed to Richard Feynman that was found on his blackboard after he died. Nobody knows if it's actually his, but that quote is like, what I cannot create, I do not understand. And at least with programming, that is pretty much true. Like, if you cannot write the code to do X, and X is a programming problem, then you probably don't understand it. And the opposite way too. Like, if you think you understand something and go to write the code and suddenly discover, like, no, I really don't get how this works at all. I mean, that's a very common experience in my life anyway, that I felt like I really got a handle on something until I actually started to write the code. And that's when my ignorance showed. So writing the code is absolutely a good idea. The thing I'm actually ambivalent about is something else, which is, so Casey has, I'll try to phrase this very diplomatically. Casey has a certain attitude of his, like, the thing that really, really annoyed me was when he went on this whole rant about how the people who work on Visual Studio are all diaper babies who don't know how anything works and they're just doing this wrong and blah, 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 and so forth.
Yeah.
And that just really rubs me the wrong way. Not for the reasons you may think you do. It's just like the problem with something like Visual Studio or Word or like any IDE, name it. These are, again, like the same thing I mentioned with Qt. These are things that are trying to be a million things to a million different people. I myself am very unhappy with a lot of things about Visual Studio that I encounter in my daily use. And it's very, very obvious that Visual Studio is not something that is intended to be used by native code developers exclusively. There's lots of stuff in there that is kind of awkward if you mainly care about native code. There's lots of things that you just never use at all, and you wonder why this is there. But the whole thing is like, Visual Studio is used by a lot of native code developers. It's also used by people who write in C# or in F#, or who do database queries using LINQ, and so forth. So like, it tries to be a lot of different things. And it's just sort of trying to be this jack of all trades, which means that anything in particular you do will probably not the best thing you could do if you try to focus on doing one thing well. And there's this old Unix philosophy thing about trying to write programs that do one thing and do it well. And that had a good run. And quoting Rob Pike, that attitude is dead and buried, and the eulogy was delivered by Perl. Because even in the Unix space, people eventually ended up writing either these monster shell scripts or ended up writing a lot of things in Perl. Because it turns out that this jack of all trades language has regular expression facilities, has lots of ways to call into other code, has random libraries that do everything, and it's not a particularly great language for many of the things it's used for, but it happens to work well enough for people that are familiar with it to be productive. So yes, Perl is not the best tool for many of the things that it's actually used for, but it is a tool that gets stuff done and that people are familiar with. And Visual Studio is in sort of the same space, where it has such market saturation that it's just used by very different types of developers that want very different things in an IDE. And many of the things in Visual Studio I'm not happy with. But I also realize that being a native code developer with very, very specific interests, like leaning towards, for example, at least soft real-time tasks and lots of media stuff. Like, I care a lot about intrinsics and like Cindy stuff and so on in my daily work, which is something that many C++ programmers don't ever use at all. And it's just very, very narrow sort of thing that I happen to care about. Looks like the stream is gone.
No. You can't see it.
I can't see it. I'll stop talking until the stream's back.
Okay. Show the video.
Yes. There's a big panic in the chat. Yep. Yes. Yep.